Hi, this is Alex from devstories.eu. GitLab CI/CD, episode 13 of 14. Your pipeline just failed because someone updated a shared YAML snippet 3 repositories over. You had no warning, and now you are spending an hour fixing a job you did not even write. The days of relying on fragile, unversioned YAML snippets are over. CI/CD components and the CI/CD catalog fix this by bringing package manager reliability directly to your pipelines. Components are reusable, single-purpose pipeline configurations. They act as the modern evolution of the old include template method. With legacy templates, you essentially imported raw YAML over the network. If the upstream file changed, your pipeline changed instantly, often with disastrous results. Components solve this by enforcing strict versioning. The CI/CD catalog serves as the centralized registry where your organization can publish, discover, and share these versioned components. To build a component, you need a repository with a very specific file structure. The core logic must live inside a directory explicitly named templates. You can place multiple YAML files inside this directory, with each file representing a distinct component. At the root of the repository, you must also provide a readme.md file. This markdown file is not just a polite suggestion, it acts as the official documentation displayed in the catalog, detailing what the component does and what parameters it requires. Here is the key insight. Components are too rigid to be useful without inputs. Inputs act exactly like function arguments for your pipeline configuration. When you write the component YAML, you declare a block at the top that defines the accepted inputs. You specify their names, their default values, and whether they are required. Consider a platform engineering team rolling out mandatory security scans. They create a component project called Corporate Security. Inside the templates directory, they write a file specifically for secret detection. To keep it flexible, they define a single required input called stage. Application developers across the company no longer need to write or maintain secret detection jobs themselves. To consume that exact secret detection component, a developer uses the include component syntax in their pipeline configuration. They specify the path to the component on the server. Then they append an @ symbol followed by a semantic version such as 1.0.0. This is the crucial step. Pinning the semantic version guarantees the pipeline will never break unexpectedly, even if the platform team releases a heavily modified version 2.0.0 later that week. If a developer intentionally wants the bleeding edge, they can append the special tag ~latest instead of a version number, but semantic versioning is the safer default. Just below the include declaration, the developer passes their variables, mapping the stage input to whichever pipeline stage fits their specific project, like test or pre-built. Treating pipeline logic as versioned software changes how teams scale infrastructure. The real power of components is not just code reuse, it is the absolute guarantee that a pipeline running successfully today will run exactly the same way 6 months from now. Thanks for listening. Take care, everyone.